Hello everyone, welcome back. So today I will be solving a problem called evaluate division. It's problem number 399 on LeetCode and it's a medium problem. It's a very interesting problem. So let me just go through the problem statement once. It says you are given equations in format of a by b is equals to k, where a and b are variables represented as string and k is a real number, floating point number. Given some queries, return the answer. If the answer does not exist, return -1.0. Input always be valid. You may assume that evaluating the queries will result in no division by 0 and there is no contradiction. There is no contradiction. And here the sample input is given like this. You will be given two list of list. One is equations, another is queries. So in equations, it will be given like a comma b, which means a by b, and the value of that particular a by b is 2.0, and here b by c is 3.0, and the query is something which we need to calculate, like a by b and b by c values are given and we need to calculate a by c, and a by c value will be like this 6.000. And how we are getting this? Because a by b and b by c is given, so a by b is 2.0 and b by c is 3.0. So queries of a by c is like uh, a by b into b by c, so that's why 2.0 into 3.0 equals to 6.0. And similarly we need to calculate b by a also, because a by b is given, so b by a will be what? Just the reciprocal of that, so 1 by 2.0, and that is what is given over here 0.500. And rest of them are like, for this example, a to e, there is no way we can calculate a by e from given values b, a by b and b by c, because e is not given in this equation list of list, so that's why -1.0. So this is how we will be given an equation, queries, and these values we need to calculate the output like this. And another example is also given over here. So let's go to the constraints. It says the equation length can be maximum of 20, and each equation element will be of length 2, and equation of 1, like, it will have two values, and the first and second value will be in the range of 1 to 5, and the values length and equation length will be similar, because these equations values are given in the values array, so that's why they has to be similar, and some other constraints also. So this is the problem, and this is a very interesting problem, because at first seeing this problem it is a bit difficult to understand how we can solve this, and we can get these answers, but there is a very interesting trick behind it. So now let's go to the whiteboard and let's see how we can solve this problem.
I have taken this example from LeetCode and written down over here. So we will be given all these three values and we have to calculate the output. So first of them will be a list called equations, where a values, like a pair of values, will be given, like a comma b or b comma c or any lowercase alphabets. So what this a b and b comma c and what these values mean is basically this a comma b is 2.0, which basically implies that a by b is 2.0 and b comma c is b by c is equals to 3.0. So we now have to find out from these two values all these values. So first one is a by c or a comma c, which means we have to find out what is a by c. So we know from mathematics we can write a by c equals to a by b into b by c. So b and b gets cancelled out, we get a by c. So we know the value of a by b, right? So it is 2.0 into 3.0, so it will be 6.0, and in answer it is written like 6.000 something, so it's basically 6.0. Now the next value, b by a. So we have to find out what is b by a. So we know the value of a by b. So what is now b by a? It is nothing but basically reciprocal of a by b, which is b by a. So which means 1 by 2.0, that is 0.5. This is how we have to calculate all the other values. Now it's a comma e, so which means what? We have to find out a by e. Now we see we don't have this e in our equation. In this equation we don't have any existence of e, so that means what? This value cannot be calculated. So that means we should put minus 1 comma 0. This will be our answer. Now a comma a, so a comma a is basically a by a, so we don't really need to know what is the value of a, because anything dividing by that self is obviously 1.0 or 1.0. And the last one is x comma x. Now one thing we have to remember over here, that in case of a comma a, we are writing the answer as 1 comma 1.0. And why we can write this answer, because a is present in our equations, but this x is not present in our equation. We know that x by x will also be 1.0, but according to this question, if it's not present in this equation any of the values, then by default the answer will be minus 1.0. So first we also need to check if both these values either present in this equations list or not. If any of the values are not present, then the by default answer is 1.0. Now we understand the problem statement clearly. Now let's see how we can actually solve this problem. So by looking at it, what we actually see, let's just take this a by c example. So this a by c, we are calculating how, taking a by b into b by a. So if we observe this clearly, we can see one pattern, like we somehow have to reach from a to c, and whatever we are like taking as intermediate nodes or intermediate path, in this case it's b. There can be some other example where there will be some other multiplied values like a by b into b by a, then again into something like something by something, and so on. So what we are doing is, the end goal is, like, this is the source node, this is, let's say, intermediate node. So again here we write intermediate, intermediate, again intermediate and intermediate, and lastly we have to somehow reach this destination node. So what we are doing is, basically we are traversing like a graph, like coming here, then here, here to here. So we have to traverse a graph. So somehow now it comes to my mind, like, if I can make a graph using these values and do a graph traversal like DFS, where the starting node will be the first node of the queries and the destination node will be the last node, then it will be a directed graph, and we know the path values, like these values which are given. So if we just go and do a DFS or BFS and calculate the path values and keep on multiplying them, then we will get our answer. So this is the approach we are going to take over here. So let's see how we can build this graph. Okay, so for building this graph, we have only three nodes for this example. So what are the three nodes? It's a, three vertices, sorry, it's a, it's b, and it's c. So these are the three vertices. Now how we can calculate, how we can connect them? So a by b, which is basically there is a edge between a and b, and the value, or it's, as it's a directed and also it's a graph where the edges have values, so the value over here is 2.0. right? Now from b to c there is a path, so that's why there is an edge, and the value over here is 3.0. Now we also have to keep in mind that if there is a possible way to go to a to b, there has to be a possible way to come from b to a also. So that's why here also we have to connect, and for this connection, whatever the value is of a to b, it will be reciprocal of that, because obviously a by b is 2.0, so from b to a it will be 1 by 2.0, right? So here it will be 1.2.0, and similarly it will be 3.0. Okay, so after constructing this whole graph, what we will need to do is, we will be just looping through this queries array, and we will be taking these pairs as source and destination, and we will be checking if a path exists from this source to this destination. And if it does, then we will just continuously just keep on multiplying this path values, and we will get the answer easily. And there can be one case, like for this example, this would be a base case for our DFS function, because the source and destination will be same, because we are starting from here and we will be ending over here as well. That's why it will be our answer itself, like 1.0. And for these cases we will be checking, like, if all these source and destination are present in our graph or not. If they are not present in our graph, then we will simply return minus 1.0. So the basic Dfs function, I don't think I have to explain. If any one of you are not familiar with that, you can just check on YouTube. Like, we will be starting from here and we will be going to its adjacent like this. So from this we'll be now going to its adjacent like this, and we will also keeping track of visited array. So like for A by C over here, we will be starting from here, we go to B, then B to C. After reaching over here, what our Dfs function structure will look like is, our Dfs, let me write it over here, our Dfs will have one source, one destination, right? So first of all, our source is what? Our source is A, and our destination is always remaining C. So from here, our Dfs call makes its adjacent. So A's adjacent is what? B. So make B as source now, and C is again the destination. Now again a Dfs call. Now it makes what? B is adjacent, which is C. So C and destination is C. So we hit a base case. So it will return what? It will return direct 1.0. So after returning 1.0, we know that cost of B to C is what? 3.0. 3.0. So now this function will return over here is 3.0 into 1, 3.0. So from here we know that A to C is 2.0. So here it's 2.0 into 3.0, and this will be returned as answer 6.0. So this is how our Dfs function working. And there can be one case also, like if let's say there exists one more vertices over here which is not reachable from our source, then what will happen is all its adjacent nodes will be traveled and all will be visited, still we cannot reach our destination. So in that case, what we will return is, we will return a none. And in our main function, when I will be showing you the code, you can see in the main function we will be checking if the return value is none, then we simply put 1 minus 1.0, because the destination is not reachable from source, or else whatever the value is returned we will put in our answer. So what are the two cases I have mentioned of minus 1.0? One is either source or destination is not present in our equation, or if the destination is not reachable from our source, then also minus 1.0. So this is our whole algorithm. So basically we have to do a simple graph traversal, either BFS or either DFS, and we have to construct this graph. So basically the time complexity will be same as DFS, and space complexity also. So both will be over here is order of V plus E. So as we already know in DFS, the time and space complexity is order of V plus C. So now let's go to the code editor and let's see how we can code this problem.
So now I have already written down the code over here, because writing down live code will be taking so much time and the video will be getting longer. So now I will be explaining this code to you. First of all, as I have said, we need to build the graph. So for building the graph, we need adjacency list, right? So for that purpose, we are taking this adj list variable, and it's a default dictionary in Python. So this is how we build graph. And we are doing like node 1 and node 2 in equation, and we are associating node 2 which is connected with node 1, and the value of that edge is value of that index, right? And also similarly we have to do the reverse, because node 2 will be connected to node 1 as well, and the value of that case will be the reciprocal of whatever the value was at that index. So after completion of this whole loop, we will be having the graph in our hand. So after that, we have to return this answer. So we take an empty list of this answer, and we are at the end just returning this answer. So now, first of all, we are looping through this source and destination in queries. And as I already said that we will be checking if either source or destination, if they are not present in our graph, we simply append -1, because -1.0 will be the answer. Or else if both are present, we are calling this Dfs function from source to destination. And the Dfs function is the standard one, as I've already shown. It is the base case if the source and destination are same, like in the case of A and A, the answer will be 1.0. Or we are adding this source first of all to the visited, and then next node and cost of the neighbors of the source, and then if the next node is not in visited, then the next node will be the source again, and the destination will be remaining the same, and so on and so forth, as I already tried run in the whiteboard. So after that, if there is no path present, then it will return none, and we will be checking over here. If none is returned, we are pushing what? -1.0 to the answer. And if it's not none, whatever the result it is returning, like this result into cost, we are putting that in our answer. So after that the whole answer array will be constructed and we are just returning the answer. So it's a pretty straightforward code, and I guess you can understand this code. So let me just submit it. So after submission we can see it's getting accepted. So I hope you guys understand how to solve this problem called evaluate division. It's basically a graph traversal problem. And if you like this video and if this video was helpful to you, please make sure to like this video and subscribe, and share it with your friends. Thank you for watching.